Hello friends, a very happy new year once again. Now today we'll talk about support vector machine implementation. The previous lecture you all saw support vector regression implementation, and now it's a very small video talking about support vector machine implementation. Here we'll be taking two examples to show you the implementation using Python, and both the examples are extreme. Like one will give you very bad classification and another will give you extremely good classification, right? That is 100% and 0% classification. So let's look at the examples. And the best part is data set is same for both the examples. Now, to start with, we have taken this sample data set where we have the attributes as age, loan, and the class label as yes or no. So what we are doing is person is having of age 25 and the loan what is supposed to still pay or the pending loan is 25,000, and what we have predicted like he's not going to pay the loan, right? He's not going to repay the loan. So class label says whether the loan will be paid or no. So it is age and the loan, what is he supposed to pay and whether the chances of he making the loan payment is yes or no. This is my data set. Okay. So given data set with age and pending loan amount with the class label yes or no, whether they will pay the loan or no. So let us apply a SVM classification to this. We'll go step by step and see whether we can train our model. Now, again, importing the data set, I'm not going to talk about in detail about the training data set, testing data set, because we already spoke about it in SVR implementation. So if you want more details, go back and visit the SVR implementation video. Okay, for data processing, we import pandas, right? And the file what we are using is loan.csv. This is what I have printed the file. So this is what the output you can see is loan and the class label. So after importing the data set, what we are going to do again, as per in machine learning, what we do, we split the data into training and the testing set, right? So for that again, we are importing train test split, which will split the data into training and testing data set. Again, if you remember 80% and 20%, right? So for test, what we are using the 20% of the data. So data is split 80% into the training to train the model and 20% to test the model. So again, classifying the predictors and the target. So what we are doing from our data now, we are picking up the training data set and the testing data set into respective variables. So Xtrain will have all the training data which is related to training, and Ytrain will have the class labels, right? It will have the class labels. Now, similarly, this is 80%, this is 20%, the data related to testing and the data related to prediction of the test result. Fine. So what we have done, we have classified our data set into set of predictors and set of testers. Now, once I plot my X train just to see how it looks like, this is what is stored in my X training data, right? This is the training data and it has respective class labels. So if I just print Y train, X train is for training and Y train is to have the associated class labels associated with this data set. So it will print the class labels. So for the first array, first test record, age is 50, pending loan is 35,000. What it predicts, it is going to repay the person is going to repay the loan. Similarly, age is 70, pending loan is 10,000. It says no, the person will not repay the loan. Is it fine? The test data along with the output or the class labels, respective class labels. Fine. Okay. Next, now what we are doing is we are going to initialize the support vector machine and fitting the training data. Again, it is same like what we did in SVR. So again, what we are doing is we are using the RBF kernel. Fine. And we are going to fit the Xtrain and Ytrain. Fine. This is the warning message what will appear. So just ignore it and this is what will be there. Is it fine? This is actual screenshot of the code. Now, to predict the classes for test set, so here y predict, and what we are passing it, the X test data, and we are printing the prediction. So what it is saying, prediction is saying no, no, no. Fine. These are the class labels which are associated. Now, what we'll do is we'll attach the prediction to the test set. So here we are attaching the prediction to the test set, right? This a warning will appear. So what we do after that, we just print this test set. So once you print this test set, you can see, we can compare the actual classes and the prediction. Now, if you see, these are the 3 records which are used for testing. Now, what is the actual class label is yes. What is predicted? No. Here again, class label is actually yes. What is predicting? No. Same thing here, it is yes, but it is predicting no. So what you can see, comparing the class and the prediction column, we find that all the predictions have gone wrong, right? So the model is not fit for this data. So what is the accuracy? Now, calculate the accuracy of the prediction. So what we do again, we just print the confusion matrix. So accuracy we are using confusion matrix, which is plotted here. And what it shows, accuracy is 0.0. Why? Because all the data sets are classified wrongly. It is yes, but it is predicting it as no. Is it fine? So this example, where the SVM model is giving 0% accuracy. Fine. Now let us see another example. Okay, now this is the data set. Again, we have the same type. Here again the age, percentage of loan pending and the class. But the only difference, if you see in this data set, right here we have taken percentage of loan pending, and in the previous one, what we had actual loan. It was not percentage, it was actual amount. But here we have percentage of loan amount pending, right? Rest everything is same. Okay. Now let us see, using this data set, the same command we are using to train, only the difference is instead of loan, now here it has loan1.csv data. Rest of all the commands is same. And when you check for the accuracy, what you get, the accuracy as 1.0, that is 100% accurate. So it has 100% accurately classified the data set. So what we understand, the data set is same, but the type of data what you give for classification, right? The data needs to be normalized and standardized. So same data set, but here only we have used the percentage, and there we have directly used the amount of loan pending. Is it fine? Remember, SVM has some limitations. You cannot use it for all type of data. Mainly you can use it only for the numerical data. Fine. So I hope the concept is clear. And try to implement these 2 programs, make your own data set and see whether it is useful or not. Thank you. Stay home, stay safe.